All right, question 5. So on this one, it is a trigonometry problem. And so at first, if you try to do some U-substitutions, you'll realize very quickly that none of them are helping. So remember we said that there's two options for these ones. We can either do a U-substitution, and we can try and see if those will help us, but obviously since they're not in this case, we can try and do some trig identities to try and simplify this a little bit. So I want you to notice that 1 minus sine squared is kind of like 1 minus sine squared of theta, right? It's just 2x. And so we have a trig identity that says 1 minus sine squared is equal to cosine squared. So if I can take a picture of what I've already started writing down here, I want to show you guys how we can use trig identities. And this is actually one that you guys should be familiar with already, because we have used it before in class, many times actually. So let me try and put this over here so we can see it together. There we go. So 1 minus sine squared on the bottom becomes cosine squared of 2x. That's a trig identity that we have. From there, we have sine of 2x over cosine of 2x. Some people might get stuck here, but this hopefully looks a little bit familiar to you because we did something like this in class. So break this up again into something that looks familiar to you as far as an integral we know. So we understand, I hope, that we can break it up into 1 over cosine of 2x times sine of 2x over cosine of 2x. Because if we multiply this back together again, we have 1 sine on the top and we have 2 cosines on the bottom, so that goes back to what we had. 1 over cosine is secant, so that becomes secant of 2x, and sine over cosine is tangent, so that becomes tangent of 2x. And this is one of our integrals that we know how to take the integral of. So again, all of those steps were just leading up to preparing us to be able to take an integral we know. Now is where the U-substitution comes in. So we have 2x, okay, so I made that my u, the derivative is 2, bring that 1/2 over to the other side because we don't have a 2 in our formula. So the yellow replaces the yellow, the green replaces the green, so on and so forth. So the 1/2 I pulled out of the integral. That's where I got this from. So we have the integral of secant u tangent u du. The integral of that is secant u, right? So we have 1/2 secant u plus c, and then I just replaced u back into the equation again. So 1/2 secant of 2x plus c, and that was answer choice D. So the difficult part of this was realizing which trig functions you needed to use. But remember with trig, there's only 6 integrals that we know how to take so far in calculus. And so if you cannot make it equal one of those integrals, then that's not the way we're going to do it. So try your best to use trig functions to make it equal one of those ones we know. And again, if it doesn't equal one of those, then there must be a different way of doing it.